Hello, good afternoon. My name is Federico Pasquini. Our company, NET, is a provider of innovative gas sensing solutions based in Milan, Italy. And today we're going to talk about our latest release, which is a new refrigerant sensor module. The product is aimed at supplying a direct integration solution for HVAC or refrigeration equipment manufacturers to guarantee reliable detection of all the major A2L gases, as well as propane, as well as CO2, providing local relays to ignite alarms and RS-485 digital communication. It is based on our field-proven NDIR technology, so infrared gas detection technologies, which guarantee absence of false alarm, does not require regular maintenance or calibration, and provides a very long operating lifetime. Our gas list, mentioned before, all major A2L gases are there, as well as R290 or propane, as well as CO2 in different ranges. All the major A2L gases are provided in their classic LFL, so a lower flammable limit range. In percentage of volume here is expressed, but each of these ranges is actually the LFL. The design of the sensor has been centered around the applicable standards in the market. It features an oil spray cover that is designed to pass oil spray tests, which are a requirement of the future standards for refrigerant sensors in applications for refrigeration and air conditioning. It is available with IP65 certified environmental protection to guarantee resistance against humid or aggressive environments. As mentioned before, based on our field-proven refrigerant gas detection technology. We'll go through the advantages of our infrared technology in a second. It provides a standard Molex type connector, although it can be available also with customized connectors in case of need. It is provided with a optional bump test accessory with a bar where to connect gas in case routines require bump test at the installation or during the sensor operation. Integrated mounting holes to be installed directly inside equipment with an easy solution, and it provides two local alarm relays, one normally connected to fault condition and one normally connected to the alarm threshold at overpassing, or for example 15% LFL, 20% LFL, that is fully customizable. It is very versatile in the range of gas, in the easy integration it provides, with the digital communication, with the threshold outputs, with the local relays. It is extremely rugged, environmental range, -40, +60, so it can be installed in harsh environments, both very cold or hot. It is based on a glass reinforced flame retardant enclosure protected with that oil spray cover we mentioned before. We also have a oleophobic filter underneath that to guarantee the environmental protection and avoiding condensation on the optics. It is based on our NDIR technologies. Again, we'll go through that in a second, but that guarantee you selectivity on the gas, so it will not react to other chemicals which may be present in the environment. Very important. That means no false alarms. It is also an optical technology. Therefore, it will have total immunity from poisons and inhibitors. Other traditional technologies have problems with chemicals which can poison the sensor. Even this exposure to the gas, high exposure to the gas, to the target gas, can cause the sensor to be poisoned. That doesn't happen with an optical technology. It is fail-safe. That means the sensor cannot go in a state where it becomes unresponsive to the target gas without you knowing it. The sensor will always inform you about any fault or alarm condition. Great long-term stability. The sensor has internal self-check and self-calibration routines, and the optical nature of the gas detection technology guarantees an expected lifetime to exceed 15 years. It will undergo the highest level of certification to ensure great reliability. We will go, the sensor will be certified to IEC 6335240 NXLL. It will be certified to SEAL 2. All of our infrared sensor and in general infrared solutions have reached a level of safety intrinsic level of SEAL 2, the only infrared sensor on the market with such certified level of certified reliability. This will also undergo SEAL 2 certification. In terms of application, this is extremely flexible. It can be installed in refrigerated cabinets. It is aimed to be installed inside HVAC or refrigeration equipment directly inside the unit, chillers, rooftop units, heat pumps. It can be installed inside refrigerated trucks or trailers. It can also be installed in environments in case, such as cold room, machinery rooms. It can be used in hotel rooms, office buildings, hospitals, to monitor also VRF systems. At NET, we have been pioneering the application of infrared technology to refrigerant leak detections. We have started over 10 years ago with our first designs, and over the years we have always interacted with the market to understand needs, to understand the applications, and therefore we not only can provide the sensor, the solution, but also a very strong application support and integration support. Our range, in general, of refrigerant gas sensor covers over 40 different common refrigerants, A1, A2L, A3. We have them all in our range, and we'll keep on expanding that range as new gases are introduced into the market. That technology has been field proven, as mentioned, with over 10 years of field application, and nowadays our solutions are the best-selling infrared sensor for refrigerant leak detection in the market. Brief history of our solutions. We started, as mentioned, over 10 years ago. 2011 was our first release in the market. What we call the ERF-Pro is still our best-selling sensor for refrigerant leak detection used by instrument manufacturers worldwide. In 2018, we introduced the ERF-Lite, which is a platform which was aimed at monitoring mainly A2L gases and offering a cost-effective solution to instrument manufacturers. And our Remora module, which we are presenting today, is actually based on this technology. Last year, we released sensor modules to provide even more cost-effective solution for lightweight applications. And this year we're coming out with the complete package, the Remora module, aimed at direct integration for whoever is looking for a compact, complete, effective, simple, and reliable solution to be directly integrated into their application, into their equipment. But why is infrared technology so well suited for refrigerant leak detection? Why it is more reliable than other available technologies in the market? Let us spend our last 5 minutes talking about that. Well, not sure everybody's familiar with infrared technology. It is based on a property of gas molecule of absorbing light, absorbing energy at precise frequencies. So each gas absorbs energy at specific frequencies. So by observing energy attenuation at those wavelengths, we can determine the presence of that gas in the environment. The greater the absorption, the greater the concentration of the gas in the environment. So each gas has a specific absorption band in the infrared spectrum. And from this property derives a first great benefit of infrared technologies, which is the gas selectivity. So we can be sure, if we have attenuation of that specific, at that specific wavelength, that we have presence of that specific gas. And if there are other gases, those will operate in other areas of the spectrum, and therefore we will have no cross interferences to those other gases or chemicals. And that means no false alarms. The sensor will react to the refrigerant gas and only to the refrigerant gas. Second important property derives from how we build ourselves an infrared sensor based on the proper absorption technology, absorption property we've just seen. How it is made, an infrared sensor? Well, it's simple. We have an infrared radiation source. It can be a simple filament bulb lamp for typical hydrocarbons, gases, or CO2, or it can be a more sophisticated source like the one we use for infrared sensors. We have an optical path, which is so-called a gas chambers. This is the space traveled by the light and occupied by the gas in case of a leak. On the other hand, we have a pyroelectric detector. A pyroelectric detector is an optoelectronic component able to measure energy at specific wavelength. So we select one detector, which is called the active detector, at the precise frequency of absorption of the target gas. For example, R32. Then we select a second pyroelectric detector, which is called the reference, in an area of the spectrum where there's no absorption for that specific gas. So each measure is always compared to a reference. And that is called a differential absorption technique. So the measurement is always compared to a reference measurement, and that allows us to compensate for progressive drift, progressive contamination of the optics or the lamp, because both active and reference channels are attenuated by dose effect over time, and therefore our proportion remains intact, and that's how we keep on compensating the measurement over time. That means that NDIR sensors have greater stability than other technologies on the market who over time tend to wear down. And from that property derives the need of no maintenance. The sensor will maintain its calibration over time without periodic recalibration or frequent maintenance. Another important aspect, the sensor is how it's called fail-safe. What do you mean by fail-safe? We mentioned that before. the sensor will always inform you if there's a condition when the sensor becomes unresponsive to the gas. So if we have a situation in clean air with the sensor functioning, both active and reference are at the high level, and that means no gas in the environment. When we have a presence of the gas, then the active signal is attenuated while the reference remains intact. That means we have presence of the gas and we measure the corresponding concentration. When the IR source decays over time, or we have a deposit of contaminants on the optics, that both signals are attenuated, and therefore we can apply compensation. If one of the pyroelectric detectors fails, we have the corresponding signal dropping to zero, and that is a clear fault condition, which is signaled by the sensor. As well as we have a fail IR source. Both signals are at zero, and that is also a condition that the sensor is able to report. That is called fail-safe detection, and that means that you have no undetected risk. Last but not least, immunity to poisoning. Typical technology used in refrigerant leak detection, such as metal oxide semiconductor, can be poisoned or burned out by high exposure to the gas. This is a sketch of a test we made on an MOS sensor as well as an NDIR sensor. So both sensors were exposed to a first level of 2000 ppm. Both sensors reacted correctly. Then the sensors were exposed to 90% LEL, very high exposure. Both sensors reacted, but after that, the MOS sensor got poisoned, the zero has drifted, and a second exposure to 2000 ppm was not detected correctly. In fact, typically, after a high exposure, an MOS sensor requires recalibration, while the NDIR sensor can be exposed no matter to how much quantity of the target gas, it will always maintain its calibration. That is called immunity to poisoning, and therefore the sensor can be exposed to several leaks without having to be recalibrated. I'll go shortly on that. Resistant to environmental condition, the sensor is environmentally compensated. The sensor is self-heated by the lamp and the electronics, and therefore the humidity is not a problem in the sense that we always operate above dew point, and condensation of the optics is very rare. On the other hand, again, we mentioned Modbus communication, we might mention SIL2 operation. We can accelerate response time in case of need by operating on our firmware, because the sensor is completely digital and microprocessor based, and therefore we guarantee a great ease of integration. Okay, the sensor is available to look at our booth, which is all 5 stand 323. These are the technical data of our sensor with 2 or 3 data highlighted. These are the certification we are going through to provide the highest level of certified reliability on our sensor. All right, my 20 minutes is up. 3 p.m. sharp. I'm willing to take any question. I don't think we have time now, but I'll be available on the side here for whoever has a question. And again, you can find us at booth 5323 if you have interest on the module, you want to collect materials or have a live look at the sensor. Thank you very much indeed.